Hypervisor is extremely useful because it allows you to run multiple virtual computers on a single physical computer. Now, this is going to save you a lot of money, but it also gives you the flexibility to run different operating systems on your computer at the same time. The only problem is, if that physical computer develops a fault, or you need to take it down for maintenance, for example, then it means all of those virtual computers you're running are no longer available. So to deal with these sort of situations, it's advisable to create an actual cluster of hypervisors. And this is going to allow you to move your virtual machines from one node to another, for instance. But how do you actually create a Proxmox VE cluster? Well, if that's something you're interested in finding out, then stick around and watch this video, because that's what we're going over. Now, I'll include a timeline in this video in case there's a particular section you want to jump straight to. But before we actually start clustering these three servers that I've got together, I do want to actually cover some of the prerequisites or requirements when it comes to making clusters. Because, well, we just want to avoid running into potential problems either while we're trying to create the cluster or afterwards when we're actually dealing with virtual machines. As with any other clustering system, it's best to make sure that the actual servers you're going to be putting into your cluster are all running the same version of software. So for me, I've got three servers. Node 1's on 7.25, so is Node 2, and so is Node 3. And that's basically because just before actually starting this video creation, what I've done is to upgrade all three servers to the latest version that's available. Now, you can get away with minor differences, for example, where you're running slightly different versions of operating systems, but it is better to make sure that they're all running exactly the same version, because then there's just less likely of a chance of things going wrong, a server being refused entry into the actual cluster, or some unusual bug developing after it's actually joined, for instance. So like I say, the best strategy is really just to make sure that they're all running exactly the same version. Just like any other clustering system, you want a minimum of 3 servers in your cluster. And the reason being is that, yeah, we could just have one server in a cluster, but then, well, what's the point? You can't actually migrate a virtual machine to another hypervisor because there is only one. You could have 2 servers in the cluster, but the problem is sometimes you might get decisions need to be made, and if you've got an even number of servers, you might get a tie break. In which case, you always want an odd number of servers, at least during normal operations, which means you need at least 3 servers in your cluster. You can have more, so the next number up would be 5, for example. Entirely up to you, depends on your requirements, how many virtual machines you need to run, etc., etc. But you should really have at least 3 servers in a cluster, just because of those decisions that need to be made. You'll hear terms of like a quorum, for example, and it's just basically, it's the requirement to have a majority decision when something needs to be done. And then, like I said, the only way to guarantee that really is when you've got an odd number of servers. Now, for your typical cluster, you don't want to be mixing up vendor processors. In other words, your actual servers that you're putting into this cluster should all have Intel processors, or they should all have AMD processors, for example. You don't want a mixture of the two. They're either one or the other. You can have different clusters. You can have a cluster of servers that are just Intel processors. You can have another which is just AMD processors, but you don't want a mixture. Now, in the case of these actual 3 servers that I've got here, they're actually virtual machines. So in my case, they're all going to be identical anyway. They've all got Intel Xeon processors, E5-2650s as it turns out. But there is this extra requirement when it comes to hypervisors in that you can't even mix up the families when it comes to the actual processors. Ideally, you want all of your servers running exactly the same processor. You can get away with maybe the same processor with different clock speeds, for example, same families. The key thing is the actual instruction sets that these actual processors support, because this is going to be a big problem if there's a mismatch and you're running virtual machines and you want to try and do a live migration. So, for example, let's say we're running a virtual machine on Node 1 here, and we want to migrate it across to Node 2. Now the problem is, if this actual virtual machine that's running on this server is using a particular code set, a certain instruction set that's not available on the processors on node 2, then you just can't actually do a live migration, because what's going to happen is the actual system's going to essentially clone the virtual machine on node 1 across to node 2, and then there's going to be a brief moment where it just basically disconnects the virtual machine from node 1 and then picks up on node 2. So it's pretty much seamless in the way it does it. It's very, very clever. But the problem is, if the instruction set's not present on that other processor, it just can't continue. So that's why it's best to really make sure that the processors are identical, or you could get away with, as I said, just a difference in the clock speed maybe, but it's something you really need to be careful about. The alternative is you'd have to just shut the actual virtual machine down, then migrate it across. So it is possible, but you're missing out on live migrations in HA, for example. So something to bear in mind. Better strategy is just buy computers that have all got the exact same processor in them. Now, another important thing for clusters is that the actual date and time on your computers is the same. So in the case of Proxmox VE here, it's running on the Debian operating system. So by default, what's happening is Debian's actually trying to reach out to NTP servers on the internet to get an up-to-date date and time. So what we can do, at least within the GUI, is check and actually see what the actual date and time are. If you want to change the NTP settings, you'd have to go into the actual command line. But as long as you've got access to the internet, for these computers, as long as they've got NTP access in particular, we should be fine. All the same, we do want to check it though. So we're going to go down to here where it says system and then time. So we're showing towards about 1514. If I go to node 2, time on that one's about 1514, and node 3, that one's also showing about 1514. So these have to be in sync. Now, like I say, out of the box, they'll all be going basically to the same actual NTP servers anyway. They reach out to the same pool, and that's just because of the default settings within Debian itself. So normally you wouldn't have to do anything, but it's still worth actually checking to make sure that these clocks are in sync, and fix those before you go any further if there's a problem. Now, another thing that we need to check is that all three of our computers here have got access to the same networks. So if we go to System and then Network, you can see I've got several interfaces on this particular computer. What I've got is I've got one bridge where I've got a management interface here. Then I've got another interface which is set aside to get direct access to network storage, particularly a NAS. And then I've got another interface which is actually going to be a dedicated cluster interface. Now, you don't actually necessarily need to have a cluster interface, but it is highly recommended, because you don't want to have any problems where an actual interface that's being used for communication within the cluster gets interrupted, or it's just too noisy, too busy, because that can cause problems for the cluster. So the recommendation is to set aside an interface specifically for actual, doing the actual cluster communications. And I've also got another separate physical interface which is going to be used for the virtual machines. But what I want to do is to make sure that all of my computers have access to these same networks. So go over to node 2, go to its network settings. So again, we've got a storage network interface, a cluster, a management, and then one dedicated for the virtual machines. Go to node 3 here, again, storage interface, cluster interface, management interface, and then we've got one specifically for the virtual machines. Now, one thing I would suggest though is just double check that these actual interfaces are all active. So just go down the column, you can see they're all showing as active. You can run into issues where, for example, you might think that the actual interface is working and you find that your cluster just doesn't work. You can't actually join the actual server to the cluster, or at least it falls over, for instance. I've run into those issues where, for instance, on one particular node, the cluster interface had been created, but it was actually down and they just weren't working. But what I can do is I can actually just double check just to make sure that these servers will be able to communicate with each other. So what I can do is actually go into the shell. So here, for me, the actual cluster network that I've set aside is 172.16.23. So this is 10, this one's 11, and this one's 12. So if we drop into the shell on this particular server, so just do a quick ping, 172.16.23.10, so that's itself. And that's 11, which is node number 2, and 12 is node number 3. So just double check. Yeah, that one's 12, that one's 11, and this one will be 10. So they can all communicate, because this server can ping all the other servers, and then I know that all three should be able to communicate with each other, but there's no harm in double checking. So if we go back to this one, 172.16.23.10, yeah, we can reach that. We can talk to ourselves, and we can talk to node number 3. So we'll do a check on that one. So that one's fine. Yeah. So they can all talk to each other on that cluster interface. And the reason I'm just being extra cautious here and double checking everything is just for the sake of, yeah, if they can't talk to each other, then when we come to actually try to set up a cluster, it'll just fall over, or it'll get worse still, it actually gets part way through and then it just effectively falls over, and it's pretty messy to try and clean it up, I must admit, at least what I've found. So do double check that these computers can communicate with each other on their interfaces. Do make sure that they've all got access to the same network. So these are the interfaces that the hypervisors themselves use. This is just a bridge or virtual switch that I've set aside specifically for the virtual machines to use. In this particular case, I'm not using any VLANs, so the actual bridge itself isn't VLAN aware, but it's something to be mindful of. Make sure that the actual switch, the interface, the actual switch port, the physical switch port, they all have access to the same VLANs, for example. Otherwise, what you might find is that, say for instance, we're running a virtual machine on this node here, and it's using VLAN 100, for instance. If VLAN 100 isn't available on node 2 and we migrate the actual virtual machine from node 1 to node 2, all of a sudden your actual virtual machine is going to stop working because it can't get access to its VLAN or its network anymore. So these are things that you need to be mindful of. Do check that all of these network settings are pretty much identical, really. That's the safest bet. The only difference then is going to be things like the IP numbering that we've got, the final octet here on the actual hypervisor interfaces themselves. Otherwise, they're pretty much the same. Creating a cluster for Proxmox VE is extremely easy to do, and that's in part because we're using Debian, which has actual virtualization built into the actual kernel, but also because Proxmox have done a lot of the work in advance in readiness to actually create a cluster. For one thing, we don't have a dedicated management machine to actually look after this node, and we won't need one to look after our cluster. The actual graphical user interface is actually designed with clustering in mind, because we've got a server level here where we've got settings that are unique to the server, but we've got a data center level where we've got settings that are being shared by all of the servers. So typically when you create a cluster, you would actually just install the operating system. There'd just be clean installs, nothing on them. You would then create your cluster, and then you would start adding things into the cluster, things like connection to shared storage, user accounts, virtual machines, and so on. I've kind of just jumped the gun a bit because I've actually created a connection to my NAS on this node. I've added in an actual virtual machine as well. Now, I can get away with that because this is going to be the first node that creates the cluster. So this information will be used to actually create the cluster itself. It will be inherited, but I couldn't do that with other servers. The benefit of this approach is that by setting up the actual connection to the NAS in advance here, which has been done at an actual data center level, it means that when I add servers into the cluster, they'll inherit that same connection. So I don't have to connect each of those actual nodes to the NAS to give them access to shared storage. They just need access to the actual network where my NAS is. So it's going to make life a lot easier. And that's why, as I say, actually creating the cluster itself is so easy. So to create the cluster, we go to Data Center, then we go to Cluster. As you can see here, it's saying this is a standalone node, no cluster defined. But as I say, the layout is already there for an actual cluster. We've got a choice of create a cluster or join a cluster. So this is going to be our first node to actually be used for our cluster. So we're going to click on create cluster. It then wants to know, well, what's the actual name? So I'm going to call this lab PVE cluster. It then wants to know what our cluster network is. So as I was referring to before, it's best to have a dedicated interface for actual cluster communication. Now, it's just picked this particular link out. I click on the drop-down menu, I can select that one there. That one's going to be set aside. It's an isolated network. So I want to use that one to actually build a cluster and for all of these nodes to talk to each other. Now, as you can see, you can add in multiple links. So if you do have multiple links that are available, you can use those for failover, and that would make a lot of sense, especially in a sort of like a live production environment. In this particular case, it's just a virtual environment, so it doesn't really matter, but you would add those in. I mean, on some systems, you'll be deciding it at a BIOS level, for example. That could have already been decided. You might just have a virtual interface within the actual environment itself, but with other systems, you might actually want to click on that add button, add in another physical interface so that you get that failover, because you don't want a situation where your cluster literally breaks because they can't communicate with each other. But as I say, in my case, I've just got one link. As it's pointing out, this link number here that we've got, this is just to decide the priorities as to which one's more important than the other. When you add more links into the actual network, you can see one's got a priority of 0, one's got a priority of 1. They only need to communicate on one actual link. So it'll use this one. If this one breaks, it will use that one, for example. But I'm only going to use the one link. So that's why I took that one away. We'll then click on the create button. And it doesn't take that long, even in a sort of like a virtual environment like this. Click on the status. You see it's now stopped. It's okay. So click on the close button. And you can see now this is all changed. So it's saying, here's our cluster names, our config version in terms of configuration changes. There's one node. This is the node that we've got. And what it means is that I've now got a cluster, but as you can see, nothing's actually changed. Again, I don't need a dedicated machine to be able to manage this. All I have to do is just log into this node, for example, and I'll be able to manage the entire cluster. So it makes life a whole lot easier. Now, to actually add nodes, there's different hypervisors have different approaches, but what Proxmox have done here is they made life a bit easier. If you click on this button here, which is appeared, which is join information, we've got the IP address. So in this case, this is the management IP address of this actual server. This is its fingerprint, which we can use for security. So we can use that to basically check that when we actually join a node to the cluster, we can check we are genuinely connecting to this server. But this is the information we're interested in, this join information. It makes life a whole lot easier, because if you click on that copy information button, what it does, it copies all of the information that we've got here. And we could actually use that to tell the node that we're going to join to the cluster all of the information it needs, essentially, to then join this actual cluster. So like I say, actually creating the cluster itself is extremely easy. So with that cluster now created, the next thing to do is to start adding our nodes to that cluster. So if we go over to node 2, and if we select data center, and then click on cluster, we're going to click on the option here to join cluster. So what it's asking for is to paste in the cluster information. So we'll go back to this tab here. I'm going to just click on that copy information button. Come back to here and I'll paste that information in. Now straight away it's coming up with information based on that information that we supplied there. In other words, we've got the IP address of the peer, we've got its fingerprint, we've even got its actual IP address that it's using for its cluster interface. So you can cross-check this particular fingerprint here against the one on node 1. So that's a good security check just to make sure you are indeed joining the correct cluster. I need to provide the root password to actually join, but what I also need to do is pick out the correct interface. So fortunately, because it's actually telling me what the peer's IP address is, you can see how the two are lined up here. So now that I've done that, we're both servers here using an interface that's in the same subnet. I'm going to click on Join Lab PVE Cluster, and it's thrown an error. It's saying this host already contains virtual guests. Now, when I set these up, node 1 here has got a virtual machine on it already, and it's connected to a NAS. Node 2 has also got a virtual machine, but we've got problems because this virtual machine belongs to this specific node, and this node's literally been converted from a standalone node into an actual clustered node. So the problem I've got is that, well, you can't actually have virtual machines, even though it's turned off here. It's not in use, it just won't let me join the cluster. So I'm going to select that. I need to basically remove it. So I'm going to go to More. I'll select Remove. And I don't really have any other choice, so it's asking for the ID, so I'll put in its ID there. Yeah, well, may as well. I don't want anything to do with this virtual machine. It just can't come with us as part of the actual cluster migration, essentially. So that node has no longer got any virtual machines on it. So I'll go back to Data Center, go back to Join Cluster, and I'll grab that information again, paste that into here. Put in my root password. 0B85 is what it ends in. Select the correct link. So that's our cluster link. So we're in the same network. We'll click on Join. And then there it's going. There it's gone and set itself up to actually join the cluster. So you can see it's logged in okay. If you look at the status, it's in a state of running. Now, one thing I found is that you can actually get disconnected from the actual node that you're actually joining to the cluster, because essentially it's been removed as being a standalone server and being converted into part of an actual cluster. So yeah, this is a bit sometimes misleading. If we go back to node 1, just close that window, you can see we've now got node number 2 over here. And as you can see, it's automatically gained access to the actual NAS here. The reason it can connect to it that way is because when I set the actual server up, it does have a dedicated interface in storage. So it's got exactly the same access, essentially, to the actual node 1 server that was originally set up to get access to this NAS. So it'll go through the same process of using NFS to then log in and connect to this NFS share here. But essentially the server's actually moved across now, as far as I'm concerned. It's actually connected in, but that is just something to bear in mind, is the fact that you can't basically bring a virtual machine across with you. So it's best to really be doing this from scratch. So what I'm going to do is I'm just going to repeat the same process here for node number 3, just to finish this one off. So we'll tell that to join the cluster. We'll go over to here, we'll get our join information. And this one should go more smoothly because it doesn't actually have any virtual machines on it. So we'll pick the cluster interface. So both in the same network, 0B85. 0B85 is what it ends in. Tell that to join. So it's stopping the cluster service, as you can see. Now this is going to take a bit longer. Oh, there you go. You can see it's in the process. So once it's actually joined across, we'll see that one go green as well. There you go. So that's now joined in as well. And you can see it's now trying to connect to the same NAS share. So as you can see, the process is pretty straightforward. Just bear in mind that caveat. You don't actually have any virtual machines on these nodes that you're joining in. So what I would suggest is either start off with one server that's got all the virtual machines on them. Basically, I just don't have any at all. by all means, connect that one into your NAS. But the rest of the actual nodes you're going to join in, you just don't want anything on them really. There's no point joining them to a NAS. There's no point putting virtual machines on, because they're going to inherit all of that information when they join this cluster anyway. Well, now that our cluster's built and we've got all 3 nodes joined into this cluster, I'm going to do a bit of a tidy up, because I've got 3 tabs open, but really I only need to ever connect to node 1. So I'm just going to close those ones down. And that's it. I mean, if I ever want to manage any of these nodes, I actually could connect to either of these nodes to be able to do that, because there isn't sort of like a dedicated virtual machine that's used for management within Proxmox, which makes life a lot easier, I must admit. So if I tell it to actually connect to node 2 again, yep, I'm aware of the risks because I've got a self-signed certificate. I'll accept the risk. Login is the root. Yep, I've got no subscription. And you can see essentially I've got the same sort of information here. Really doesn't make any difference which of the nodes I connect into as such. I'm just going to get the same information anyway. So the good thing is, I mean, it is a cluster. It'll deal with picking out who's in charge and so on. And again, because we've got 3 servers, node number, there'll be a majority decision to decide that sort of thing. If you lose a server, everything still carries on. But yeah, I mean, it's a case of going forward. I mean, I don't really need to connect to node 2 or to node 3. I can just keep connecting to node 1 in future, really, if I wanted to. But if that node goes down, I could connect to one of the other 2 and still be able to manage things. But going forward, what it means now is I've got all 3 servers all joined into this one cluster, and I'll be able to do things like migrating actual virtual machines from, say, one node to another. Pretty straightforward. Just pick the actual virtual machine, click on like the migrate option, and you can pick which one do you actually want to migrate it to. So I mean, there's no point migrating it from node 1 to node 1, so it's only giving me the choice of node 2 or node 3. I quite like that it's giving you details about the memory utilization, CPU utilization, and so on. But there's a lot more than just basic migrations that you can do in here. We're into options like high availability, for example, where if an actual physical node were to fail, you could have any of the virtual machines that were on that actual hypervisor spin up after it's been detected that that server went down, for example. That gives you your high availability. You can buy some systems where you have one actual virtual machine's active maybe on node 1, but then as a standby on node 2. You could even have some systems that can run active services. So it gives you very brief outages, of any at all. They're just usually so quick that they tend to be quite seamless. But yeah, it's a very, very straightforward process, I must admit. And because we don't have to have that dedicated virtual machine to actually manage things, it frees up a lot of resources as far as I'm concerned, which makes something like this really good fun, for things like the Intel's NUCs, which don't really have that much in terms of CPU or memory availability, for example. I don't have to waste a virtual machine to be able to manage a cluster like this. So yeah, that's one of the reasons I do like Proxmox over others. Well, thanks for making it to the end of this video. I really do hope you found it useful. If so, then do click the like button and share, as that'll help get the video out to more people who might find it useful as well. If you've got any comments or suggestions, please post those in the comments section below. And if you're new to the channel and you'd like to see more content like this, then yes, do subscribe. Just remember to set the bell icon to actually send you notifications when new content gets released. Although I also post to Twitter as well as Facebook. If you'd like to help the channel and support it, you can actually make contributions through PayPal and Buy Me a Coffee. I've also got links to Patreon, and there's also the join membership option for YouTube itself. Patreon and YouTube members do have the option to actually benefit from early access as well. But above all, many thanks for watching this video. I'll see you in the next one.